Okay, this is section 4.3. This is number 17, the homework problems. And what we want to do in number 17 was find the actually wanted to find the points of inflection, points of inflection. So first of all, we take the first derivative. We're going to use the second derivative test to find the points of inflection. And if we take the first derivative here, this is the function y equals x to the 1/3 times x to the -4. Now rather than do something like the product rule, what I'll do is I'll just multiply this out, distribute it, and make it into two terms that are very easy to differentiate by using the power rule. Product rule is a little more difficult. Power rule is a little bit easier. So we'll use the power rule. And then we just multiply, use 4/3 times x, and subtract 1, we get 1/3. And then 1/3 times 4 is 4/3, it's -4/3. And if I subtract 1 from 1/3, I get -2/3. And that's the first derivative. Then I have to do the same thing again, so I take the second derivative, so that's 1/3 times 4/3 is 4/9. X to the -2/3, and then negative times a negative is positive. 2 times 4 is 8, 3 times 3 is 9, so it's 8/9. And x, and if I subtract 3/3 from 2/3, I get -5/3. And again, we want to check this, so what we're going to do is try to get one fraction. So first of all, I'll put these as denominators to make them positive exponents. The negative exponents are very hard to deal with. And then again, I've got two fractions here, so I'll make that into one fraction. So I've got to find the LCD. The LCD is going to be, looks like it's going to be 9x, got 9's and x to the 5/3. So I'll multiply the top and the bottom here by x to the 3/3, which is x to the first. And if I add 3/3 to 2/3, I get 5/3. So now I've got a common denominator. 3/3 is 1, so this is just 4x to the first power plus 8. And I've got the common denominator of 9x to the 5/3. So it's not, we want to see where is it going to be undefined or when is it going to be 0. Those will be the points, the critical points where we have possible concavity changes. So it's going to be undefined when the denominator is equal to 0, so that's just when x is equal to 0. And it's going to be equal to 0 when the numerator is equal to 0, so 4x plus 8 equals 0, so x equals -2. All right, so those are my two possible points of inflection, so I have to put them into the graph here and check. Make sure there's a change of concavity, otherwise they aren't points of inflection. So let's find actually what the points are. This is -2. If I put -2 back in the original function, I've got the original function was x to the 1/3 and then times x minus 4. So -2 to the 1/3, -2, -4. That's going to be, well, a negative to the 1/3 power is a negative, so just -2 to the 1/3. We don't really know what this is, so we'll leave it like this, and that's -6. A negative times a negative is positive, so that becomes +6 times the cube root of 2. And if I put 0 in the original function, 0, it's going to be 0 times that, so that just be 0. So those are my two possible points. So I put these in here. -2 and 0, and I try y double prime of -3, and if I put -3 in here, if I put -3 in here, and negative to the 5/3 is just going to be some kind of negative, so I'll just look at the fraction. That's going to be negative in the denominator. If I put negative in the top, 4 times -3 is -12 plus 8, that's negative, so I got negative in the top also. So negative in the top and negative in the bottom of a fraction, top and bottom of this fraction, is going to make this positive. Then I tried -1, and -1 is going to be a negative in the bottom. Of course, anything negative to the 5/3 would be negative. I don't have to worry about the value. It's going to be -9, but that's not the issue. And in the top, I just have a -1. That's going to be positive because that's going to be -4 plus 8, which is positive. So I got a positive over a negative, and that makes the fraction, this whole fraction, negative. That's my second derivative. And then again, I could put 1. 4 times 1 is 12. That's going to be positive. And if I put 1 in here, +1, that's just going to be 1. So I have positive over positive, which is positive. So what I do have is I have changes of concavity happening here because this is positive, so it's concave up. This is negative, concave down. This is positive, concave up. So this is my second derivative test, and I'm checking for points of inflection, and these definitely are the x values of the points of inflection. What I did over here was find the y values, so these are the points. So I can say that -2, 6 times the cube root of 2, and 0, 0 are points of inflection because concavity changes there. I go concave up, concave down, concave down, concave up. So I hope that helps.